Okay.
All right, hello everybody. I'd like to welcome you to my talk with Matt Siegler. Um, teenyBIG focuses on audience engagement, and I help a lot of nonprofits really try to understand how to explain their expertise to the general public and to non-experts in their field. And so I thought, what better way to get some perspective on this than talk to an actual rocket scientist? And in talking to an actual rocket scientist, I realized that rocket scientist isn't actually a thing. And so I think we could talk a little bit about why that is even a term. So I want to welcome Matt Siegler to this talk. Matt, why don't you tell us a little bit about what you do?
Okay. Hi. I'm Matt, and I do science with things that go on rockets to place. But the people that make the rockets are engineers. I always say there's no such thing as a rocket scientist. That the people doing that, the rockets are these brave engineers that actually get us to the place we want to go. But so I work on a variety of missions that NASA sends to places like Mars or the Moon or Mercury to take data. Some of them fly around the planet and some of them land on the surface. And so I'm really excited. I'm working on the new Mars rover that's going to land on Mars on February 18th of this year. So that's an exciting new project. And hopefully you all either will watch that land or did watch that land if you're watching this after that.
Excellent. So, what is your specific expertise?
So I do anything involving temperatures on planets. So you've all seen like infrared cameras in movies and such, night vision cameras. Basically, we do instruments that are that same concept. And one of the big things I work on is the poles of the moon. So the moon has such a small tilt that the craters near the North and South Pole never get any direct sunlight in them. So we can't just take a picture of those places. But with an infrared camera, we can actually see into the darkness. And I do things like mapping out those temperatures, and from the temperature, we can figure out if there might be ice under the ground. And then I do other things like where we'll drill into a planet to try to look for how temperatures change as you go down under the ground, and that tells you about the heat coming out of the interior, and that in turn tells us about the composition of the planet as a whole, which tells us something about how the planet's formed and all that. So it all links to some bigger picture all the time.
Okay. Yes, definitely outside of most people's everyday experience. But
But
that
that's the
makes
problem is everyone I know, that's their everyday experience. So
yeah.
so it feels boring to me.
Yeah. Well, I definitely can understand drilling holes and shadows. That those concepts make sense to me. But tell me a bit about why you might need to talk about some of these things to non-experts.
I mean, the foremost reason, and maybe this is something common to a lot of your nonprofits, is we're government funded. The taxpayers are paying for this field to exist, and I know that's a luxury that um, that my job even exists. And that I need to make sure that people understand it to a level that they support it. That when it comes time to vote, you might support the congressperson that has some support of NASA science and what we could do. Um, I mean, so that's really one reason, is just for your own continuation. But and for me, it's is that I see space exploration and all this as something I'd like to see. You know, there's a cool aspect of exploring and pushing out and pushing to the frontiers of science that is something I'd like to see society do, and like people to understand that excitement and push out in their own lives beyond and see that there's something bigger out there. And NASA has always just been like a good example of, oh, here's something big and far out in the future. We can be better in the future. We could do something better as a future, as a society. So it's a it's a carrot out there for the whole world.
Yeah, it's definitely bringing to mind all the, aim for the stars, land on the moon, and the analogies that come out of the moon landing that you hear all the time. It's definitely inspirational to a lot of different fields.
Yeah, it's a positive vision for the future.
Yeah.
That's what I'd like to push forward to society. And just the general use of science in your daily life for decision making is very good. When it boils down to it, that's what science is a tool set for knowing whether someone's lying to you or not. And we might see that's a very useful thing in our society right now, to
It
know
is.
when
It
someone's
is.
lying to you or not.
Yes, there's definitely got to dodge some of that. So, so I think having the motivation is one thing, but then explaining some of these complex ideas to people is another. Can you give us an example or two of a way you've tried to get your concept across and you've learned something from it?
Um, yeah, I mean, I guess with these far out concepts, or with any specific concept from your distinct discipline, right? You try to come up with some analogy. And I think what you often find is the analogy you use doesn't work to other people. And you have to practice and fail a bunch of times. Like, one of the best learning opportunities I had was when I was a graduate student. I worked part-time as a museum guide at the Griffith Observatory in Los Angeles. And that was really great, because there'd be some script basically you would be saying about, like, this exhibit, like, oh, this is how this thing works. And you'd tell people, and then you'd realize, like, one time, like, oh, they didn't get that at all. And actually, if I think about it, what I said with that analogy is totally wrong, and I need to come up with, so um, there's there's things like, a good one was explaining how the tides work on a planet. Like, why do we have a high tide? And it has something to do with the moon's gravity. And there are all these analogies out there, including things in textbooks, and most of them are wrong, and explaining this kind of basic idea that controls so much of our ocean, and when it's a good time to surf or not, like all these things. And so it was really a great experience to, one time I remember trying to explain the tides to some patron at the museum, and they came back to me and, like, that doesn't sound right, but we
What was the
exchanged
analogy
emails.
you used?
What?
What was the wrong analogy you used?
Oh, that it's kind of like the moon pulling on the water, and that lifts it up, right? But
Yeah.
then, so that there's a high tide on the side of the earth facing the moon, but there's also a high tide on the side of the earth facing away from the moon. So what's going on if gravity is this pulling force? And then, so then we, like, exchanged a bunch of emails, and then I came up with different analogies, and tried to get them. And the one that finally clicked for both me and the person was to talk about, like, okay, gravity is an acceleration. We're all used to accelerations. When you hit your gas pedal, going faster in the car. And so that's all that gravity is. Gravity is acceleration. And gravity gets weaker with distance, just like a light gets dimmer with distance. And so as you got further away from the source of the gravity, it would get weaker. And so what's going on is the gravity of the moon is pulling a little more on one side of the earth than the other. And so now think about that in terms of acceleration. Think of a train that's accelerating, right? As it's speeding up, and now the front of the train is going faster than the back of the train, and you have these, like, couples between the cars, right, that are a little stretchy. And so what happens if you speed up the front of the train faster than the back of the train is it actually stretches out, right? And so here's this, now, like, the picture of the earth, like, with the going into the oval shape, the oceans are more stretchy than the rock, right? And so that's why we get this tide lifted up in that shape. And that was an example of an analogy that worked. I had to break it down into something that was familiar to people. Like, most people have ridden a train, most people saw these links between the train, or some picture, like, of a train might stretch out. like that, and by breaking it down into analogies, and maybe you watching this still didn't get it after that, so maybe I still need to work on the analogy.
Well, I can kind of see that the idea of the magnetic pole has always been like a quick concept, and so I think what you're explaining explains it further, but it's maybe like the next level of detail that explains why why it's not directly analogous to magnets.
Yeah, and so yeah, it's sometimes you realize that the analogies you've been using break down and you need to come up with a different one. And I think that's an important thing, is to just go out there and test your analogies that you're using to explain your thing, and realize which explanations don't work or not. So, teaching and outreach or whatever are kind of a good way to learn yourself.
Yeah. Well, that fits a lot with the way I work too. So I really believe that there are levels of understanding people can have about a complex concept, so that maybe initially they need to hear something, and then as they understand it, they might need to hear something more in depth. But similar to what you said, a lot of my work revolves around being human centered and using research and talking to people, which it sounds like you did with this example, like really bouncing ideas back and forth. So not only talking to people, but also getting concepts in front of them so you can see how they react to it.
Yeah, and then that's something you can't do with your colleagues that are also specialists, because you like get halfway through your sentence and they understand what you mean. And so you get lazy in your speech that you're always, that you're like, oh, well, you get that. So I don't need to give a further explanation, and because you have some common background that you're understanding that idea from. And so you do have to, when you're trying to reach people outside of your specialization, you got to practice with people outside your specialization.
Yeah, no, that makes a lot of sense to me. So beyond talking to people, are there different strategies you use to explain concepts to non-scientists? So I'm thinking like if you have this new thing you need to talk to people about, and you need to explain it to non-experts, before you start talking to people, before you start testing, are there some strategies that you use to think about how you might explain it to somebody?
Yeah, I mean, I guess the first thing you have to do is relate it to something that they're actually interested in, and because a lot of times if this was something someone's explained to me recently, like when you're talking to another specialist, you like start from the very basic background and you build up and you build up and you build up, until you get to the like, oh, here's the punchline at the end, the special thing that I want you to, relate this to this big concept. But when you're talking to someone, they're so bored, by the time you're halfway through, if you approach it that way, and so you kind of have to lead the the exciting part first. And so then you've got them caught a little, and then they want to know the background and how it, where that idea came from, and so like I say like, oh, I look for ice on the moon or something like that is my job, and then I like usually later explain like, oh, and we do that with these temperature probes, and then we do that, from orbit, but we also can do it with this other wavelength of light that, and you get into all these details that would be pretty boring to someone if you started with them. But by starting with the punchline, basically, you can grab the audience first, and then you.
How does that feel as a scientist? Like, do you ever feel like you're dumbing your ideas down, or especially when you have to say something that might not fully be scientifically correct?
I mean, yeah, and that's why it won't feel satisfying until you figure out the right analogy that's not dumbing it down. And that's why you have to practice a bunch of different ways, is that I think when it clicks, when you have a real fundamental understanding of the idea you're trying to explain, then it does feel right, and it's going to feel wrong until you've quite gotten that, so if it feels like you're lying to yourself in explaining to it, then you probably need to work on your analogy for yourself, even if that, and I mean, I think as far as are you dumbing it down, I mean, I think it's that you're trying to, I mean, you're not using jargon and specialized, and so like that's almost dumbing it down, is when you like force everything into a bunch of jargon and such without giving the explanation of this jargon, that like if I just, I don't know, I'm trying now I'm getting lost on where I was going, but
well, no, I never thought of jargon as dumbing down, but you're right. Like, I mean, jargon is meant to like imply a whole bunch of stuff to somebody who understands that word, and so you are kind of cheating a bit. You're not actually, you don't even necessarily have to know what it means. You just have to know the jargon and the context. So I think that's an interesting way to look at these words that we use that non-experts might not get.
And it feels like in some way is admitting you don't understand the idea, is if you only can revert to the jargon.
Yeah.
If you really understand an idea, then you can explain it in a way that doesn't require the jargon.
Yeah. Do you have any favorite examples of ways to kind of quickly explain some science concepts?
I mean, I like, and this was, I'm a scientist now, but I was a film major in college. And so I've kind of always had a visual way of doing it. So I think, videos and, YouTube has a lot of great things out there right now to explain things very quickly and adding this visual way. I mean, so that's one good way of doing it, is to make, quick, snappy product. Like, this is one of these things that's happened with a lot of conferences going online this last year. A few people have, gone to the effort of making basically little short documentaries. And normally you'd go to a conference, you give a 10 or 15-minute speech about your work. And then you realize when you like make it into this, quick, video with visuals and everything, like you could explain everything that took you 15 minutes before in the first 2 minutes, because it's just a more exciting, punchy way to explain things. And so having a good product that you can make and give to people with a clear, distinct explanation, and a lot of times that's a visual language, and at least that's the language that speaks to me very well. So is that what you meant by that question, or?
I guess just any examples. Like I'm trying to think, when you were talking about, how you typically use the magnet idea with tides, and we find ice on Mars analogy before. I'm just curious, like just even if it's more outside of your specific expertise, if you've seen some good examples of explaining a complex concept quickly.
Yeah, like one that you get a lot is, global warming, right? And this is something that I have in one of my classes that I teach students about. Is they're all, it's an intro class, they're not experts in science or whatever, and how, it's just such a political buzz thing, global warming, but what it boils down to a certain thing that you explain, that there are certain molecules that, like carbon dioxide and water vapor, these things we have in our atmosphere, that like to absorb infrared light. They like to absorb heat, but not visible light. So visible light passes right through them. The ground heats up, gives off infrared light, and gives off heat. And that tries to escape, right? But these molecules, they're the right size, that they wiggle at the right way, at that wave will make them wiggle. And so they'll absorb that energy when it wiggles. And then they give it off and give it off and give it off. And sometimes they'll give it up and sometimes they'll give it down. But if you have enough of them, when the one above you, you give it up to them, they'll give it back down, right? So there's this idea is that you have, one way the light can come in and then it can't get out as efficiently. It's a blanket that bounces it back, right? And so the more of those molecules you have in the atmosphere, the less of that heat will get back out. So that's a pretty straightforward concept, is this: the more you have of this thing in the atmosphere, the less heat will get out. And that's the whole thing, right? And you don't need to go into more details about like, and this, history of how the Earth has changed in and out of these climates for the past, like going into too much detail, but just to get across, if you have more carbon dioxide in the atmosphere, less of this color of light, this wavelength of light, infrared light, can get out. And so what's going to happen? Well, you're going to trap more heat in and you're going to heat up. Like, I don't know. Is that...
It kind of makes me feel like when you put on a wool sweater in the winter versus like a light linen jacket where something's breathable or not, like it's going to trap in more heat and
and well, that's the thing, is like we use this jargon word of the greenhouse effect, and everyone's heard that, right? But like there's not really a understanding, I think, of, it's just a word now. It's not. Whereas that's that idea, is that there's glass is one of these things, right? Light can go in and then it heats up the seats of your car, right? And then that heat wants to get out, but it doesn't. The glass is good at blocking infrared light, and it can, and then if you have the right tool handy, you can say, look, here's this infrared camera and a piece of glass and you can't see through it. So we'll do that with tour groups or whatever. We would have infrared camera and you'd point to someone wearing glasses and you'd see that their glasses look black or something like that. If you have the tool handy, that's what I was saying about the visual medium. If you like can have the tool handy to make that analogy. So that was the real simple thing that we could do at the museum, for instance, where you had an infrared camera. You'd say like, oh, look, like here's this person and look, they're wearing glasses and their eyes look black. But now if they tilt their glasses up, their eyes are like glowing hot. And you can see, if you put them back down, that heat from the eyes isn't getting to the camera. Right. And so that visual then like explain the whole thing right there. It's like, well, if you have something that can block the heat from getting out, what happens to that heat? and so that's what I mean about like having the right visuals at hand makes the whole thing a lot easier.
Well, I can kind of see there's sort of like learning by example, which would be like having those tools to do the experiment, like the glasses you were talking about. There's having the visual, which I've learned if you don't have a YouTube video, you can use your hands to describe stuff. and then there's also having then the analogy that maybe can get a concept across when you don't have the visuals or experiments to get across.
So that I use the analogy of your car getting hot in the winter. Like the inside your car is still warm in the winter, even because.
Well, and another thing you brought up, when you mentioned the greenhouse effect, I think that is also interesting to see when words start to follow, go beyond their original meaning and take on these different contexts as they are used politically, as they are used, anecdotally, and that sometimes you might have to come up with a new word or make sure you're talking about the same thing when you start with people. That's one of the things
because there are some words that if you lead with that thing, you'll just shut down your audience. And if I led by saying like, oh, the greenhouse effect is explained this way, that might lose a lot of people that are like, oh, I've heard of that before. That's not something I agree with. So I'm not going to listen to the rest of what you're saying. So you do have to approach it from like, okay, here's this other thing, and I'm going to explain it to you, and then you agree with it, and you're like, okay, I have this experience with my car being warm in the winter, even though it's cold outside. And then you say, oh, and by the way, we call that the greenhouse effect. And they're like, oh, that's what the greenhouse effect? Like, whereas before they would have shut themselves off to that idea entirely. And so I'm sure every field has that kind of analogy where, oh, this is something with waste treatment. And people are like, oh, that sounds yucky. I don't want to listen to the rest of this or whatever.
Well, I'm sure when you're in your group of scientists, everyone has a similar understanding of the greenhouse effect. And so it might be easy to forget.
Well, and that's kind of what I'm saying is like when you really learn it, you sometimes realize that there's some scientist that hasn't necessarily had the same need to, or practice doing analogy with people, and actually just know the jargon and never really, really got it to heart, the idea below. I mean, so you can't take it for granted that everyone in your specialty even necessarily has the same fundamental understanding if they've never been forced to explain it to someone in that way. And really being forced out of your box is a good way to have to explain it.
Yeah, I always like to let people know about the concept of the curse of knowledge, and that the more you actually know about something, the harder it is to remember not knowing it.
Yeah.
And then, which makes it very difficult to explain it to other people. You realize this when you have a kid and you have to, figure out how to walk and go to the bathroom and eat, and they're just things that you never really forget what it's like to learn them. And so I think the same is true for a lot of experts who spend a lot of time studying and doing, and it can be hard to then remember what it was like before.
Yeah, and I think that's that's a bad thing for my field, for instance, right? Is a lot of people that would be very good scientists are scared out early on because they have a professor that like, to get a job as a professor at a good university, you have to be this, top of your field. And sometimes those people just always had it easy, always were able to learn easily. And so they, now when they're confronted with someone who can't learn it as easy as them, they don't even register
maybe in
that.
a different way.
And so there are students that would be good, would be good scientists in their career, but they're scared out of it at a young age because the person that's been given the job of trying to explain it to them is just never had to deal with a challenge along the way.
Yeah, well, that's a good way to look at it too. It's not just about engaging your audience, but also prospective people in the field and stakeholders of various kinds. Um, well, Matt, this has been really, really interesting to kind of hear about expertise from a science perspective, especially when there's so much going on of needing to figure out truths and realities. Is there anything you'd like to leave us with? Maybe a little bit about how we can find out about your is there a rocket launch coming up?
Oh yeah.
Your rocket scientistness?
Mars is far away, so it takes like, I think this one takes 8 months to get there. So it launched last year. That was landing on February 18th. It should be fun to watch the new Mars rover land. And I'm going to work on the radar instrument on there, which is to try to map layers underground. And I'm trying to figure out how to map temperatures underground with it. And so, yeah, there's a lot of neat, exciting things coming up in space exploration this year. We always hear about SpaceX and their cool launches, but there's, right now, for instance, on Mars, it's not just the NASA landing something, but also in February, China is going to have their first orbiter and lander around Mars, and the United Arab Emirates is sending a mission to orbit Mars. And so it's this fun, exciting field to have all that going on.
Assuming there's no pandemic on Mars right now, so it might be a nice little getaway.
Yeah, it's all right. They can cluster there. They can have, but it's going to be Mars is going to be crowded. But yeah, I mean, and it's, I guess from what you've been talking about, it just reminds me of how important it is to get your ideas across to the public, because, I haven't so far, but a lot of close friends of mine have gone and talked in front of Congress and, are lobbying for this thing, right? It's because, that Mars mission I talked about is a $2 billion mission. It's not something that the country should just totally instantly get behind. You have to, convince people that all these things, that pushing those boundaries, that the fundamental science that you're learning from it is worth that. Because a lot of people might not agree with that, and rightly so. And I, and it's, again, that it's, as a kind of like a nonprofit, like what a lot of your businesses sound like they are, is, you have this luxury of existing because of what society has agreed is worth making tax-free, or making, worth supporting. And so there's definitely a reason to give back just on that basis.
Mm-hmm. Yeah, that makes a lot of sense. Well, thank you for your time, Matt, and thank you everyone for listening. If you have any questions, you can always go to teenyBIG.com and reach out to me there, or you can email me at emily@teenyBIG.com. And I look forward to talking to you soon. All right. Thank you, Matt.
Thank you.